Hello and welcome to Wood's Tuition. Today we're going to be talking about dynamics, in particular projectile motion. So projectile motion is whenever an object is moving freely in the Earth's gravity. So what that means is whenever we have an object, for example, a ball, and it is kicked in the air, it will follow a curve that is completely free of external forces. So in reality, we will have things like wind resistance and those the sort of friction forces that the ball will feel. But for dynamics, we just ignore these, especially at GCSE. So whenever a ball is in motion, it'll have an initial velocity. Okay, so that is given by this arrow here. And an initial velocity, as we've seen before, can be split into a vertical and a horizontal component. So if we have an angle, and we'll call this angle theta, we can resolve that angle, so we can close the angle, and cos is close. Let's say this velocity is initially u. Then we will have our horizontal velocity as u cos theta. To resolve it in the vertical direction, we need to use our sine, so we'll have u sine theta. Okay, so those are the vertical and horizontal motions, or angles, that make up our resultant velocity. So whenever something is along this path of motion, there will be one force acting on it, and that's Earth's gravity, as shown in the definition of projectile motion. And as we know, Earth's gravity always moves towards the core of the Earth. So for anything coming around the Earth in orbit, it is pulling it towards the core. So what that means for us in projectile motion is that there's only gravity forcing the object down. There's no horizontal component on gravity. And whenever I talk about gravity as a force, essentially what I'm talking about is that the acceleration is due to the force felt by gravity. So the acceleration will be 9.81 meters per second, and that will be felt going down. Okay. As there is no horizontal acceleration, the horizontal acceleration is equal to 0, then we know from Newton's law, Newton's first law, that a body in motion stays in motion, or if moving, continues to move unless an unbalanced force acts on it. So here we have no unbalanced forces acting on the body in motion, so it'll just continue to move, and it will retain the horizontal component of the velocity. So I will say that velocity horizontal is equal to constant. So if we think about the actual projectile, so let's say a ball, and a ball is kicked and it follows this sort of projectile motion. Initially the ball will have a velocity, and the velocity in the vertical direction, will decrease. Here it'll be a little bit lower, and it'll keep on decreasing until at the very top it momentarily goes to 0. Okay, so whenever the velocity at the top is 0, it still has a horizontal velocity, but then there's no component of vertical component. We can actually see that if we think about mass, the gradient of the curve of the parabola here would be equal to 0. So that means that the dy by dx at that point is equal to 0. Just if you want to think about it mathematically. So however, whenever the projectile continues to move, the vertical component, it'll no longer be going up, it'll be coming down. So the vertical component will get greater and greater as it accelerates towards the floor, before the point instantaneously, just before it reaches the end of its motion, the velocity vertical will be equal to the velocity vertical right at the end. So this leads us to some interesting mathematics. So right in the middle, we know that the velocity in the vertical is equal to 0. Okay, so using our equation I'll move it down slightly. Using the equation v is equal to u plus at, the final velocity is equal to the initial velocity plus the acceleration and the time. We know that the final velocity, and it's not quite the final velocity, but it's just for this part of the motion. So the final velocity at this part of the motion is equal to 0. So we can say 0 is equal to the initial velocity. And And we know the initial velocity, that's u sine 0, or u sine theta, sorry, is equal to u sine theta plus the acceleration due to gravity, which would be 9.81 times the time. And now, what's interesting about the acceleration due to gravity is you need to put in the whether it's positive or a negative value. So in this case, we've decided that u sine 0 or u sine theta is a positive value, and so up is positive in this case. And therefore, as the acceleration due to gravity is always pulling the projectile down towards the Earth, we have to say that that is negative, as we've taken positive as up. So because of this, we'll be able to resolve it and say that 9.81 t is equal to u sine theta. Therefore, the t is equal to u sine theta over 9.81. And that gives us our time, or the time halfway through the motion. So if we know the time halfway through the motion, then we're able to say that that plus that will give us the entire time. So the whole time will just be double the time halfway through the motion. So we can just say that 2t is equal to 2 times this, so which would be equal to the total time. So if we know the total time, we can use another equation, and that is for the range. So the range of the equation, we'll be able to find that the so we use the equation of motion, s is equal to ut plus a half at squared. Okay, and we've said earlier that the acceleration in the horizontal direction is equal to 0. So we can say that s is equal to ut plus 0, as whenever a, or acceleration, is equal to 0, this whole factor is equal to 0. So s is just equal to ut. So the total range is equal to the horizontal component of velocity, which we took as u cos theta. So that'll be u cos theta times time. So we want to expand this a little bit further. We can say that s is equal to u cos theta times time, and we know the time is equal to 2, so we'll put that in brackets just to make it all very clear, 2 u sine theta over 9.81. Okay, so we can actually make this simpler again. So we can take out our u's, and they become u squared. So that's u times u, and that is also 2u squared over 9.81 is equal to cos, not equal to, s is our equal to, and then that's sine theta cos theta. So what I'm actually going to do is move this 2 over here, and 2 sine theta cos theta is actually a mathematical formula that you might know, you might not, but essentially 2 sine theta cos theta is equal to sine 2 theta. So you should cover that in GCSE maths. So u squared over 9.81 sine 2 theta is equal to our range of the projectile motion. So essentially, I haven't actually used any real numbers here apart from for acceleration, but you're able to use formula and just general logic, and looking at the equation of motion and thinking, right, so there's a vertical component of acceleration, but there's no horizontal component. So due to that there, we have a constant horizontal velocity the whole way through, whereas their vertical velocity is changing. And due to that, we're able to do a lot of maths with our projectile motion, including finding the range and finding the total time, and also finding a general equation for the range. So that's all very interesting, and I can go through a couple of questions if you would like me to. Let me know. All right, thank you very much.